In this video, we will be focusing on configuration of ipv6 tunnels. We will be starting with the ipv6 manual tunnel. Now, before we start with the tunnel configuration, we need to understand, or rather we need to check whether our underlying ipv4 setup is working fine. Just to go back to the diagram. We have ipv4 between among router 2, 3 and 4. I have configured a loopback interface on each router with the router number as the loopback, that is all 2, all 3 and all 4. And routing has been pre-configured, so I should be getting the routes. Just to show you, the rep version 2 is running. Okay, let me check the routes. So I'm getting updates from 4 and from 3, and I should be able to ping using my loopback interface all 2. Alright, okay, I'm not able to ping. Must be some problem. Let's check on 4. Okay, so we're not getting any routes on 4. Let me quickly verify what's the problem. Well, there is no access list, no nothing. We see on 3. Okay, so seems to have not configured a frame random map on the serial interface. So that's the issue. Alright, that will take care of connectivity. Here we go. So I should be able to ping 2. Fine. Now, why are we doing this is unless and until you have your underlying protocol, that was ipv4, which is going to act as a transport protocol over here, is not properly configured, ipv6 tunnel is not going to be successful. And same is true for any tunnel. The underlying transport has to be perfectly configured. So we have end-to-end reachability. Now I'll start with the tunnel configuration. We are starting with ipv6 manual mode. Just to show the steps which are involved over here. Right? We will be configuring source and destination as ipv4, which are going to act as a tunnel header. And the ipv6 address must be configured on the tunnel interface. So it is going to just act as a continuation of your ipv6 topology. Fine. Now I'm going to configure tunnel interface. You can use whichever number you love. The first 2 commands are important: tunnel source and tunnel destination. Keep in mind, these tunnel source and destination are going to be ipv4 addresses. Okay, tunnel destination is going to be, now what you'll notice is when I mention tunnel destination, okay, the interface will come up. See, so point-to-point tunnel, source and destination are reachable, tunnel is up. If you configure wrong address, or if these addresses for some reason are not reachable, tunnel interface will remain down. Okay. Right. Tunnel mode is going to be ipv6 IP, and I need to configure an ipv6 address over here. Have we chosen anything in terms of IP address? No. So anyway, I'm going to keep an address 24. It's actually not 24. 24 is hexadecimal address. Pardon me for the habit of saying that. Let's keep a subnet of 2. Address Alright, so we are good to go. Alright, it's 2. Source and destination, alright, reachable. Transfer protocol IPv6. If you don't configure, if you don't mention anything more, the default is going to be JRE-IP. But pretty much the work and configuration remain absolutely same. Nothing changes. We are done with router 2. Let's check the IPv6 configuration as well. What you find interesting is that the host address over here has been derived out of the 32-bit IP address. Alright. Let's go to 4. Supposed to do the same. I mean, what number you're keeping over here and there absolutely doesn't matter. Okay, tunnel source, loop back, tunnel destination. Now, tunnel destination is supposed to be all 2, just for the sake of it. Right? Now, we do not have any route for 2. Sorry. Right? And the interface remains down. Right, the interface is down. So that's what I was saying. Do you need to configure the address correctly? Now what about this? There's no such address. That is supposed to be all 2, but the tunnel interface come up because we have route for, right? That's what I meant when I said you need to configure right addresses, and these addresses must be routable. So the address is routable, but the address is wrong. It's supposed to be, alright, tunnel mode IPv6 IP, and I need to assign an IPv6 address over here. Now we're done with the tunnel configuration on both IP router 2 and router 4. Okay, the tunnel interface, again the last 32 bits are derived from your IPv4 address. So we seems to have configured the tunnel interface between R2 and R4. But what we wish to achieve is a connectivity between R1 and R5. Now we already have R1, R2 configured with OSPF v3 and R4, R5 as well. If you just configure tunnel interface with OSPF, mind it, manual tunnel can do support routing since they are point-to-point. So we can configure routing over point-to-point tunnel interface, right? Once we configure OSPF over these tunnel interfaces, we will be having end-to-end connectivity. It will appear that router 2 and 4 are just connected with a DZ line or direct serial connectivity. There is absolutely no IPv4 cloud or nothing in between them, right? So I'm going to configure OSPF on the tunnel interface. It's a point-to-point interface, so there is no DRB here. It's going to be IPv6. I configured tunnel 2. So the neighbor has come up. Fine. We have OSPF neighbor. Again, the router ID is going to be all 4 or the IPv4 address. So we are having a OSPF neighbor relationship through the tunnel interface. Fine, the state is full. Okay, so am I getting the routes on R1? I am. I'm getting the routes for 22, right? And I should be able to get everything. I'm getting routes of R1 over here, right? So we have all-round connectivity. We have end-to-end routing. Now the last thing which we're supposed to do is we are going to check the. I will use some use ping command rather to check the reachability. So I'll go on router 1. Okay. With global unicast address, you do not have to mention the outgoing interface, right? We have connectivity. Let's trace. So the way it's going is it's going to router 2. From then on, it goes to tunnel, and finally reaching router 5, right? Well, there appears to be no IPv4 network in between. Okay, so we have connectivity end to end. That was the target. That is what we have achieved. But we would like to see what is happening in terms of encapsulation. Okay, so I'll be going to router 2. All right. I'll save the output in the buffer. Now, what are we going to do is we're sending traffic, IPv6 traffic from R1 to R5, and when it reaches R2, R2 is supposed to encapsulate this traffic going towards R4, and the return traffic coming from R4 is going to be decapsulated, right? So we would like to get some reworks on these encapsulation and decapsulation. Right? Let's go to 2. Okay. This is what we wanted to see. Okay. IPv6 IP packet has been encapsulated with the source address of all 2 and destination address of all 4 going towards R4. Now the return traffic which is coming in, okay, so you're doing encapsulation and decapsulation. You are decapsulating these packets which are going to come back to you. The traffic being sent across is being encapsulated. Okay, let's do some more debugs on 4. Matter of fact, we can only see few debugs coming out here. Alright. Excellent. These are routing updates you are receiving. Right. These are routing updates you are receiving through tunnel interface, getting encapsulated and decapsulated. Okay. So let me just clear the log. Let's see what is happening on 4. You see again the encapsulation and decapsulation taking place. Right, we have managed to capture the decapsulated packet. This is the internal packet, right? The ipv6 address of router 1 and ipv6 address of router 5 after decapsulation. Let me check the log. See what is happening. This is what you're receiving. All right, the source and destination are all 2 and all 4. This is the outer header. You remove it. Well, this is the decapsulated packet. Okay, here is what you're getting is inside information. So this is the inner header. This is what we wanted to see. I think so. This router is running a different version, hence we are able to get these kind of logs. 12.5 for advanced enterprise. And okay, now this is happening on router 2 and 4. Basically, these are 2 tunnel endpoints. Okay, and that's fine. Now we would also like to see what is happening on R3. Now R3 is purely IPv4, so it would only be looking into tunnel packet. Now the tunnel packet would be having a protocol number of 41. So let's try to get something on router 3 as well. What router 3 would be doing is, let me explain that to you as well. Router 3 is having information regarding these loopbacks, right? So whenever it receives information from 4 going towards 2, it just send it outside this interface. It uses the CEF, CEF for forwarding information, and anything going forwarded rather using CEF, I won't be able to debug it. So I'm going to disable CEF on the interface. Fine. I don't want to crowd my screen with numerous messages, so I'm just going to store the log output on the buffer. Let me have a debug IB packet detail command. That's the command which you're going to dread running in a prediction network, sometime in the lab environment also. So I'm putting it onto the buffer, right? Let me ping, and let's see whether we're getting any packets with protocol 41. Right, we are. Here is information coming with the source address of all 2 and destination address of all 4. The protocol is 41. Right. So as far as 3 is concerned, there is only tunnel traffic which is passing through. Okay, no IPv6 traffic. IPv6 traffic has been encapsulated under this protocol header. Okay. Now we discussed something about protocol 41 getting filtered, right? And if that happens, you won't be able to get your tunnel working properly. So let me clear the logs. Mind it, it's a protocol. Okay, protocol number 41. So I'm going to deny it, formatting everything. I'm going to put this on any one interface will do. The name was tunnel. Okay, so we are not allowing protocol 41 on 3. Let's see the impact over here. Our neighbor relation is still up. we missed a hello packet, right? Supposed to be received after every 10 seconds, isn't it? See, so missing all the hello packets. Try ping, not working, and our neighbor relationship will be resetting. We are into initial stage, right? So things are not working properly. We'll go and remove the access group over here. All right. So we have removed the ACL, and we should be able to get the tunnel working back to normal. You can see the neighbor coming up. Right. Let's go to one and check it. So that was about the protocol 41. Now since we are at it, at present our tunnel mode is ipv6 IP, right? Let me also show you how to configure GRA IP on it. The only thing which I need to change is the tunnel mode. Okay. Mind it, GRA IP is a default tunnel mode. You don't configure anything. That's the default mode. Anything would be sent across as an IP packet. So GRA supports multiple protocols, including ipv6. 2 tunnel mode. Oops. All right. So changing the mode, nothing else. GRE is going to work just as a point-to-point tunnel. Everything remains same. The only thing which is going to be different is the protocol number 47. That apart, everything remains same. So let me see whether we have any issue with the neighbor. Still there. Hello timers, right? Going smoothly. Ooh. What happened over here? Ah, fine. We go to 1. Okay. What will change is, as I told you, the protocol number 47. And where can you figure that out? Well, obviously on 3. Fine. So let's see whether we capture something with 47. You see, this is the only thing which changes. Okay, so everything remains same. The protocol number 47. So what also is different is the GRE packet is a bit heavy with extra bytes being added for GRE encapsulation. So IPv6 IP is pretty light, and if you just want to encapsulate IPv6 or IPv4, makes sense to use IPv6 IP. Nevertheless, GRE will work absolutely fine the same manner without any problem, right? So that was about the manual tunnel. We have seen how to configure manual tunnel, how routing is enabled on it, and how to check various debugs and other commands, right? So let's get onto the slide now. And what are we supposed to take next is manual 64 automatic tunnel. Now, when you talk about 64 automatic tunnel, there are a couple of differences compared to manual tunnel. First difference is we have a multi-point tunnel. So it's something very similar to a frame relay, where you can have multiple destinations. It's not a point-to-point tunnel, it's a multi-point tunnel. So I can establish tunnel with various location, multiple location. It can be rather extremely helpful in case you have multiple locations to communicate. Rather than pulling out a individual one-to-one tunnel, you can use a single automatic tunnel to communicate with multiple locations. Always convenient. But the difference does not end just there. The prefix is automatically assigned with 64 tunnel. What prefix are we talking about? Well, let me pause the recording for. All right. So coming back to 64 tunnel. 64 tunnel being multi-point, we do not specify destination. So let's say on router 2 I configured 64 tunnel. I would just be mentioning tunnel source. Tunnel destination can be either R3 or R4. So we cannot configure a manual destination. It is not a point-to-point tunnel. Good. Question is, how does the tunnel figure? How does tunnel figure where it is supposed to forward this information to? So how tunnel work, whether it's supposed to be sending information to 3 or 4, or the tunnel basically is going to get connected with 3 or 4. That's where the encapsulation or prefix is going to be important. So going back to the slide, with 64 tunnel we are using a global unicast 2002. That's the prefix again, 2002 rather. That's a 16-bit prefix which is reserved for 64 automatic tunnel. Keeping lab in mind, you can use any prefix, not an issue, but in a real world environment, 2002, got to get the habit out of this is not 2002, it's 2002 hexadecimal again. So this particular prefix is reserved. Now what about the 48-bit, right? So we have a network portion of 48 bits. So what about the rest of the 32-bit? The rest of the 32 bits are derived out of the tunnel source and tunnel destination. So your tunnel source is going to provide the tunnel header. Sorry, the tunnel source would be derived from the loopback interface or whichever is your tunnel source as a ipv4 packet. That ipv4 packet would be appended into the next 32-bit. Okay. So let's say your loopback over here is all 2. Okay, that's the 32-bit address of that's the 32-bit tunnel source which you have. Now you convert all 2 into hexadecimal. It's going to be 202 202. So you would be appending you would be appending 202 202 in front of 2002. Let me explain you this way. Okay, so ipv6 64 16-bit prefix. right? 32-bit IP address 2.2.2.2. Now you want to convert the 32-bit into hexadecimal, right? It's going to be 02 02 02 02. So my resulting 48-bit prefix, okay, will be 2002 202 202. Okay, that's my 48-bit prefix. So far what we have seen with tunnel interfaces doing is using the 32-bit address as in the host portion. With 64 tunnel, 32-bit IPv4 prefix is going to be part of the IPv6 48-bit address. That's the difference between 64 automatic tunnel and manual tunnel. With the same virtue, the destination address, let's say the destination IPv4 address would be what? 4. Okay, so your address is going to be 202.404.404. okay, so if the IPv6 destination is 404.404, it would be translated into all 4, and then your router is going to look into the route for all 4 and is going to forward the information accordingly. If let's say the destination is all 3, the IPv6 prefix is going to be 202 and 303.303. So again, the 32-bit prefix or 32-bit portion would be converted into IPv4 is going to be all 3. Check the route for all 3 and forward the information. So this is the difference between 64 and your manual tunnel. With 64 tunnel, we are using the IPv4 address which you mentioned in the source and destination, okay, as a part, as an integral part of your IPv6 address. So when I show this practically to you, we would be much more clear about it. Now multicast is not supported. Since multicast is not supported, no IPv6 routing protocol is supported, or API, GRP, OSPF, none. BGP is supported because it uses does it use multicast? Static routes. Static routes absolutely will not be having any problem. Okay, so let's configure automatic tunnel. And we already have a tunnel configured. I'll rather remove it. Okay, I guess I asked somewhere, did I? Why are we using next hop as link local address? I mean, link local addresses are not routable, isn't it? So why routing protocol is using link local addresses the next hop? It can very well use global unicast address, isn't it? If you're using link local address as next hop, which IPv6 routing protocol do, when you start renumbering, okay, let's say you are using a specific IP unicast global pool and you start renumbering, you start using another pool, or you shift from one ISP to another ISP, the next hop or the routes, default route, no need to change anything, isn't it? That's great, because if you imagine the same scenario happening with IPv4, IPv4 renumbering can be a nightmare for a network administrator, right? Everything from DNS, routing entries and filters and whatnot, basically everything needs to be changed. So just a small tip on why are we using link local address. All right, we have removed the tunnel interface. Let me get rid of this tunnel 2 as well. Fine. So any existing configuration is gone. Okay, we're going to create ipv6 manual automatic tunnels. So now tunnel source is going to be loopback 0. Okay, and 32-bit portion of your loopback interface would be now part of ipv6 address. Tunnel destination, right? This command is not applicable. Okay, so all I need to do is to mention tunnel mode. Tunnel mode is going to be ipv6 IP at 64. The moment you do it, the interface will come up automatically. See? Okay, I need to configure an ipv6 address over here. So what is going to be my ipv6 address? Prefix 2002. I'm on router 4. My loopback is all 4, right? So it's going to be 404, 404. You can use subnet of your own choice. Oops. Right? And host entries. That will be fine. So that gives us a 64-bit prefix. Show int tunnel. Okay, so the tunnel mode is ipv6 64. Tunnel destination is unknown. That would be derived using the ipv4 address. Okay, show ipv6. What you can see is your loopback address is now part of 48-bit prefix. That's the difference. Have I configured anything over here? No. So tunnel tunnel source, tunnel mode. Alright, on ipv6 address. Okay, it's going to be 202. One thing that to remember is that ipv6 64 automatic tunnel is primarily going to be used over internet, and the loopback interface has to be routable because you're appending the 32-bit portion from loopback into a global unicast address, right? So this 32-bit portion must be public. If it is not routable, if it is not public, okay, I'm sorry about routable rather, it has to be public over here. If it is not public IP, it won't be able to work. So I need to have this particular IP address as public. That's important, that's necessary for 64 tunnel. Okay. Fine. Checking if is 0. Okay, that's the global unicast address, that's the subnet. So we are done with ipv6 tunnel configuration or interface configuration. Since we are not going to configure routing protocol, that is not supported, we are left with static routes. Now you have to start thinking in terms of connectivity. At present, I mean, what's interesting is that the back-to-back, I mean, it's not a point-to-point tunnel. The back-to-back connectivity, we are in different subnets, we are in different network over here. So, what we do is, first thing, we are going to route everything starting with 2002 on the tunnel. Alright. I'm going to do the same. What else? The issue is we are having different ipv6 prefix configured on router 1 and 5, right? If you check the diagram, right? So there's 2000, 200111 and 2001 2222. These are two different global prefix, unicast global prefix which we have. So we need to have connectivity across tunnel interface for these routes as well. Let's say on R4 I would be configuring to reach 2002 1. Okay, the next hop can be, or rather will be, I need to go to 2. Right, that's the prefix being used between router 4 and 5. Next hop is going to be what the hell used. So we have configured the static routes, but the issue again is that we are running OSPF between router 4, router 2 and router 1. So I need to redistribute. Rather than redistributing, I'm going to simply generate a default route. I'm giving an always command because we do not have a static default route. If you have a static default route, you can configure, or you can just give default information original, that would be sufficient. So let me see whether we are getting default route. It would be an external entry, right? Mind it, we do not have end-to-end connectivity with OSPF, so we're not getting anything else. We should be getting same over here as well, right? So let's try to ping the address. Fine, we have connectivity. Okay, now let us go and debug on 2. Now what happens is you have source at all 4 and destination is all 2. Okay, so how are we able to get this information? Well,